Find the sum to n terms of the following series. Okay, let us begin. So here we have a sum. We're going to denote it by Sn. The first term that's given by 1 cube over 1. The second term that's given by 1 cube added to 2 cube whole divided by 1 plus 3 added to 1 cube plus 2 cube plus 3 cube whole divided by 1 plus 3 plus 5. Okay, then we have the rest of the terms. Now let's try to predict what's the nth term is going to be. So we know that if we follow the trend, the nth term in the numerator part we have 1 cube plus 2 cube plus 3 cube all the way up to n cube. So this gives us the sum of the cubes of the first n natural numbers. And in the denominator we have 1 plus 3 plus 5 all the way up to n. Okay, so this is going to be the nth term of the series. So here let Tn be the nth term of the series. So that's given by 1 cube plus 2 cube all the way up to n cube divided by 1 plus 3 plus 5 all the way up to n. Now we know there's a standard formula for adding the sum of the cubes of first n natural number, and that is given by n squared multiplied to n plus 1 whole squared divided by 4. This is a standard formula. And then we have 1 plus 3 plus, so this is an arithmetic series. So for the denominator, we have an arithmetic series given by 1 plus 3 plus 5 all the way up to n. So let's try to find out the sum up to n terms, because it's a sum, so that will be given by n over 2 multiplied to 2 times a plus n minus 1 times the common difference t. This is the standard formula. So here n is going to stay as n because we have n number of terms. So we have n over 2 multiplied to 2 times the first term. So first term being 1, so we have 2. A will be simply 2 added to n minus 1 times the common difference. So here for this arithmetic series, the common difference that's equals to 2. This is going to give us n over 2 multiplied to 2 plus 2n minus 2. So here 2 and 2 gets factored out. Then we have n over 2 multiplied to n. So this is simply going to be n squared. So that means in the denominator we have n squared. Now we can factor out n squared from the numerator and the denominator, and that leaves us with Tn. The nth term of the series is 1 over 4 multiplied to n plus 1 whole squared. But when we expand it, we get n squared plus 2n plus 1. So this is going to be the nth term of the series. Now that we have the nth term, we can find out the sum of the n terms, because the sum of the n terms is simply take the summation of the nth term of the series. So here, but what we'll do, instead of using the index n, we're going to replace with k, where the k is going to run from 1 to n. In other words, what we're trying to find out is summation of 1 over 4 times k squared plus 2k plus 1, and thus k runs from 1 to n. Okay, so let's try to find out the sum. So sum Sn comes out to be equals to 1 over 4 multiplied to summation of k squared. So k runs from 1 to n. Added to, we have 2 over 4 multiplied to summation k running from 1 to n. Added to 1 over 4 multiplied to the summation of 1 with k running from 1 to n. Okay, so that will be equals to 1 over 4. Now summation of k squared, we have a standard formula given by n times n plus 1 multiplied to 2n plus 1 whole divided by 6 added to, so 2 over 4, that's simply going to be 1 half multiplied to summation of k, so that's n times n plus 1 divided by 2 added to 1 over 4 multiplied to, so summation of 1, there is simply 1 added to itself n number of times, so we have 1 times n, or we get n. Okay, so when we simplify this, we're finally going to get n over 24. This will get multiplied to 2n squared plus 9n added to 13. So I'm leaving the algebra part for you. So the sum up to n terms of the series, so this particular series, that comes out to be n over 24 multiplied to 2n squared plus 9n plus 13.